Hi everyone, Risk Mr. Thrive and Survive. This is going to be a little bit of a complex video, but not too bad. A moonlight experiment was done with candles, and this was done by the person you know as the Edge on the Edge of Truth, and he just started a brand new channel, which I'm going to talk about here in a little bit. But let's get into this experiment first, and then we'll get to talking about that. What he did was, and this will make a lot more sense here in a second when you can actually see this, he created, I believe it was 5 or 6 candles on each side he used styrofoam. He put candles down on each side of a board with a partition in the middle. He had a window with the moonlight. This was the last full moon, so this is the March full moon. I believe it was the 23rd. Is that the correct date? I'm trying to remember. The 23rd full moon that occurred in 2016, March. So this was supposedly the supermoon. He had this all ready to go, and it was cloudy, of course, in the UK, like it always is. But he woke up in the middle of the night, and lo and behold, there was some clearing, and then the moon was out, and he did this experiment. Now, you will see in a second that what he did simply was he took this device he made, he lined up candles on both sides of the partition, and he put it up against the windowsill so that this partition shaded candles on the right side, whereas candles on the other side were not shaded. Now, there's something very important, which he did not plan on, but ended up working out brilliantly. And this helped confirm the results. In his window, there is a pole that is in the middle of the window, and that cast a shadow on the center candle on the other side. The side that was facing the moonlight had a pole in the window. Let me move it over a little bit here like this, which caused the shadow from that. Okay, sorry, I'm not a very good artist here, but anyway, the pole that was in the middle of the window caused a shadow to be cast on the middle candle. And as we talked about this, you will find out that this was exactly the opposite bias of what we were expecting. So let's take a look at this. Now, the first thing we're going to see here, this is what I was just trying to show you, a piece of styrofoam. He just stuck the candles in here so that they were embedded in the bottom. We'll count them here in a second, how many there were. This was I believe this was the side that was exposed to the moonlight. So what he did was he placed this up against the window, and the middle partition here had candles on the other side, which were shaded the whole time from the moonlight. So what I want you to notice in particular here is the amount of wax that is left on the candle. It's a little bit hard to tell, but I'm going to let it go ahead and play here so that you can see how they are all the way down, and then we'll stop and go back and take a look at this more carefully. Okay, this is the side in shade from the moonlight here first. I'm going to stop it there. See how it's burned all the way down, the wax. The very first one I showed you had some a little bit left. I'm not sure if that was the lit side or not. I think that was the other side. But anyway, this is the side that was in the shade from the moonlight. See how the candles have almost no wax left at all. The one on the end's got the most, which is very little. The rest is just they're gone. In fact, these burnt out first. They literally burnt out. I think he said 10 to 15 minutes before the other side eventually burned out. Now here are the ones in the moonlight. Notice the difference. right away. Look how much of the wax is left in that candle there. You can see some left there. Now he estimated it was about a 15 to 20% difference, moonlit to non-moonlit side. But the next candle I want you to pay particular attention to. Look how that's burned all the way down. Look at the next one after that. It's got plenty more just like the others up here. That middle one, guys, is the one that was shaded. Now at first, before I even saw this and we were talking about it, I said, well, the middle one should be hotter because it's got the other two candles on the outside. So there are 5 candles in the middle one. You know, it's got heat from the other candles maybe coming around to it. Well, that was the opposite of what actually should have happened. Then I also was postulating that maybe it's a little bit cooler normally on the window side versus the shaded side. But this thing with that was in the shade, this is the one that was in the shade because of the pole on the window, absolutely eliminated that as a possibility. So let's look at it again. Again, this is the moonlit side. They did not burn down as far as the other side. Actually, I think there may be 6 there. I'm not sure. It doesn't matter. All right, here's the shaded side. And hopefully I can make this larger. Good. On the end, there's a little bit there, but totally gone wax, totally gone, about 95% gone on the shaded side. So what we ended up with, you're not seeing the whole picture there, sorry. Let me see if I can drag this over. Now you're seeing this one had a little bit left towards the end. But these right here, this is the most, but all the ones in the center on the shaded side, okay? So no doubt about it, the shaded side burned down more than the other side. So that was sort of against what we were really expecting, actually. We were expecting it to be the other side. However, there have been PhDs and physicists that have looked at this. Take a look at this right here. Now, before I read this, guys, the postulation was that the moonlight, whether it's cooler or not, would cause the candles or any fire to burn brighter, burn longer, burn higher, whereas sunshine tends to mute candles or fire, anything like that. Now, that may be true. I don't know. We didn't test the height of the flame that was actually burning, but when we read this, this is sort of counterintuitive to what we were thinking. However, the results we got actually, according to physicists who have looked at this, indicates that the moonlight is cooler. Whether it actually causes the fire to burn more or not, we have to do other experiments with. But check this out. When you cool down the surroundings around the candle, more heat is transferred away from the pool of melted wax around the wick. You end up with a smaller pool of melted wax. The distance that the molten wax travels from the edge of the pool to the wick is shorter, so there is less opportunity to heat up the wax. Therefore, the viscosity of the wax at the base of the wick is higher. The resistance to traveling up the wick is greater, so there is less wax fed up to the wick. The flame in a cold environment would, for that reason alone, be expected to be smaller. Also, the fact that you are adding cooler air into the decomposing wax would also tend to slow down that part of the overall combustion process. So, I would submit that the lower temperatures causes an increase in wax viscosity at the base of the wick, slowing the amount of wax which travels up the wick and causing the candle in a low temperature environment to burn more slowly. Let me read that again, that last part. So I would submit that the lower temperatures, which is what we've been postulating from the moon, cause an increase in wax viscosity at the base of the wick, slowing the amount of wax which travels up the wick and causing the candle in a low temperature environment to burn more slowly. If it burns more slowly, you're going to have more wick, you're going to have more of the candle wax left. This is exactly what we observed. And the one where the pole was shaded that middle candle, that actually burned faster, indicating that the moonlight is warmer. Okay, so this is another witness, another way of looking at this that indicates that if for no other reason the moon, which should be reflecting warmer, you know, if the moonlight is 1/7 the brightness of the sun, which I believe it is, we should have 1/7 heating as we do with sunlight if it's reflecting sunlight. This is not what we observe. We have some people to date who have not observed, or their experiments with their conditions have not observed cooling, but nobody has observed warming, which is what we should expect. This right here is a verification without direct temperature. This is a different way. This is a secondary way to know that moonlight is producing different results than what we would expect with the moon reflecting sunlight. So I think that's fascinating in itself, and I'm going to show you something right here for more reading. Okay, you can see these references here, and this link, which I will have in the description box below. You can look at things that are related to this, and you can search wax on the page when you get there, and that will get you started. And these are different references from different people that have actually looked at this. Now, they're not looking at moonlight being cooler, they're just looking at cooler temperatures versus warmer temperatures and its effect on candle wax. Interesting stuff, guys. We're proving it. We are proving it ourselves. This is real science. When's the last time Neil Tyson deGrasse went out there and did an actual science experiment? Dropping something and saying that its gravity is not an experiment. To me, that just proved that the microphone was thicker than the atmosphere that it wore, the liquid that it was falling through. The viscosity, or rather the density of the microphone was more than air acts as a liquid, than the liquid it was falling through. What an idiot. Anyway, so here you have it. Now, a perception thing that Dave came up with and his new channel. Okay, there you have it. There is Dave's new video, and let me get in a little bit to this, and even someone who is as dense as I am with trying to get down visual things and perspective and things like that, even I got this. Let me show you a little piece of this video. I'm going to direct you here with a card to where it is on the edge of truth, because there I can have you just simply click on it. It'll take you to the video and you can subscribe to Dave's channel. This is going to be excellent because he is fantastic, especially with perspective and different things like that. But let's take a look at something in particular with this video that I want you to pick up on when you get there. Okay, now remember, Dave is known as The Edge right now, on the Edge of Truth. I don't know if he's going to be known as his new channel name or not. Either way, I totally get this, and I got it the first time, which is excellent. He is absolutely correct where he says the sun's path after it rises, when it rises in the morning, it should be at its highest point, and then it should dip down as it gets closer to us and go back up if we are living on a globe. And he explains why. And if you can think about living on the globe and then you're turning to eventually get to where the fixed object of the sun is, it would have to be at its highest point at the edge of the earth where you're looking, and as you got closer to it, as you spun closer to it, it would get lower in the sky, not higher. This is absolutely correct, and it's one of those things you just never think about because you've been so brainwashed to look at things and say, oh, that's just normal, that's the way we would see it. So anyway, click the little eye in the upper right hand corner. It'll take you right to his video, and then you can subscribe to it. So again, I'm posting it on the Edge of Truth, and on there I can actually have where I can upload this video. You can have a link that'll take you right to his homepage on the channel, so you can subscribe to which I'm sure is going to be fantastic videos coming both directly on YouTube and on the Edge of Truth. Thanks, guys. Hope you found this informative. Spread the word. We're getting more and more evidence. We're going to have an evidence section by itself on the Edge of Truth. And I've got a lot more announcements about that and other things about the site coming soon. Take care, guys. Bye.